me check my voice. Is everything okay? Let me check my voice. Yes. Things are fine. Let me check my voice. Hi guys, so welcome back to VinVout. So today I thought of doing a live PCB designing. This is because I got another sponsorship from another country. Another company. PCB designing. This is because I got another sponsorship from another country. Another company. The phone was on, so there comes an issue of echo. So anyway, so I got a sponsorship from another company called Seed Studio. So I wanted to try another PCB design. So I got a sponsorship from another company called Seed Studio. So I wanted to try. I forgot to turn off the sound from the tab that I opened. So anyway, so let's start. So I got a sponsorship. As I said, I got a sponsorship from another company called Seed Studio. So I thought of making a PCB design for the ESP32. If you have worked with this, you know that it doesn't fit right on a breadboard. It fits awkwardly on a breadboard. It's really hard to make projects with that. So I thought of making a breakout board for this thing with some additional features. So without further ado, let's get started. So let me just so we will be using this EC so we will be using this software called the ECEDA for designing our schematics and the PCB itself. So here I have already done with the schematics. Here we have the ESP32 and I have added some female header pins to it with which have the solder pads so that you can directly solder if you want. And here I have added some extra 3.3 volt and 5 volt, also some ground pins. It's always useful if you have some extra pins. And right here we have the 12 volt conversion to 5 volt. You can directly give 12 volt input to the ESP32 using this circuit right here. It will convert it to 5 volt and we can connect it to the VIN pin of the ESP32 and can work with that. So as you can see here, we have a power jack for it and a voltage regulator and some decoupling capacitors and all. And I have added another female header for that so that I can take 12 volt itself if I need. I added this because for some sensors and all, yeah, for example, you will be needing 12 volt for a motor driver, right? So it's better to have a 12 volt right there. And here I have some other. This is actually for another project. Especially I can connect it to MPU 6050. It's a gyroscope. So it's actually for another project, but I thought of merging this with this PCB board itself, because since it have the SCL and SDA, we can use it also for the purpose of connecting with an OLED, since it is the pins used for the SPI or I2C, I mean. So SPI have the two pins. So anyway, let's start the conversion to the PCB. So let's click on the convert schematic to PCB. Let me just think it's going fine. Joshua is my friend and he always gives the best. So let's keep going. So here we have everything, and let's first arrange the layout for this. I have already tried this, but I need it, like I may place it right there. That's a good position, and this may go right here. That's good. This can go right. Yeah, this is good. And so these are the header pins. It also have the solder pad, so we can solder if we want to. And here we have the DC power jack. This circuit is actually for the 12 volt conversion, as I have already told. And let me just place it right there. This might be fine. This will be fine. Adjust the capacitors. I need to turn off the where is it? Yeah, I don't need the ground rad lines. I don't need the ground rad lines since I'm just going to pour copper all over it. So again, I don't need to make these things complicated, so it will be easy for me to do the routing also. So here we go, this right, yeah, it's perfect. Yeah, I can align it later. Here we go with another one. I need to rename it. It's actually C3. I have already searched for other capacitors. That's why the silk string came to be C3, or the text came to be C3. And this is fine, I think. Yeah, this is okay. This is good. Let me just place it right here. It also comes right here. This is the pins for the MPU 6050. That's the gyroscope. I need to make sure that I'm putting it the right way, otherwise I don't have any choice after I make the PCB. So let me just look, am I doing the right way? So this is the MPU 6050. So it's VCC should come right there, then only I can do, then only it will be in my way. So I need to, yeah, I think that's the VCC right there. That's ground. The next one should be a CL, next one should be SDA. Yeah, so this is right. Okay, let me just put it right there. Here we have the 5 volt and 3.3 volt pins. I can just put it right there. Yeah, this will be good. Yeah, it's okay. Something is missing. No, this is the ground pin. That's why it is not showing any rat lines. I have already turned that off. Let me just should go right here. Yeah, it's okay. Or should I? Yeah, this should go right there. Let me think about it. While doing this PCB design, we need to make sure that these things are in the app position itself. Otherwise, you cannot do anything after they reach you. This is the 12 volt pin, right? That's good. It doesn't have any problem. Okay, that's okay. Now, need to place this. Let me align this first, otherwise it would like a mess. Here we go. Here we have the, where is it? Somewhere right there. I think align view. Yeah, format. So it should be aligned. Line. Nope. Line left. Nope, it's not that. Just looking for format, align bottom. Yeah, and these should also be lined, align bottom. Yeah, that's fine. That's good. So I'm also going to add touchpads for this. Since this is a breakout board, we should also add some kind of input. It's not necessary, but for the sake of fun, I'm going to add. So first of all, I'm gonna make a rectangle. Let its size be like, where is it? 8.5 millimeter by 8.5 millimeter, and I need to expose the copper. I can just shorten this. Don't need that much. Just need to place. This will be fine. This will be fine. So this is a touchpad. I think I need to connect it to the, let me just go and look for the ESP32 pin out. Where is it? So yeah, I can connect it to GPIO 13. It's a touch pin. It's actually touch 4. So first of all, what I need to do for that is I need to copy this one, the net, copy it, and I need to add a net for this. That will be the same as U13. So now you can see I have got the right line for that. So now I'm able to connect it. So that's it. Need to add some holes right there. It's not good. Let me just, holes needed. Holes are needed. Yes. That's okay. Yes. First of all, let me just check the dimension of this. Oh, no. So it's like 6.5 millimeter wide, and let me look for the next one. Is it? Yeah. Here we go. Yeah, it's somewhat like 6 centimeter. Yeah, that's good. That'll be fine for. That'll be fine. That will be fine. Maybe I can add another one too, another touchpad also. So for that, I'm going to just adjust it right here. Just can be adjusted. Yeah, that's fine. Let me adjust this too. Okay, that's it. Yeah, as I said, I'm going to do this. I can just copy it right there, and I'm sorry, copy, paste. Let me just place this. Yep, that will be fine. I'm going to change the net. I think I have another one. Let me just look at the pinout. Yeah, I have touch 9 on GPIO 32, so I'm going to take this one right there. Where is the 32? Yeah, this is the one. So I need to copy the net of this, that is U16, Control C, paste it right there, and yeah, here you go. Here you have the red line. So yes, yeah, that's good. Now let's start the routing process. Just need to adjust it a little bit. Yeah, that's okay. That's good. That's good. So let's start the routing. It's time to route. So I'll go right there. This is my favorite part. Routing is my favorite part. This can also be the least favorite. That's good. These are all ground. I don't need to connect them. me change it to the bottom layer, and this is fine. That's ground. There is no need to route that one. Yeah, I need to go right there, from there, from there. This should be fine. Yeah, that's good. Now, oh no, okay. I need to go from here. Oh, I can't do that. That's not good. Let me think about it. Problem. Yeah, this will be fine, I think. Oh, it's not fine. Not fine. I can just yeah. Yeah, that's good. Let's keep going. Let's route. That's good. Can go right all the way right here. Just move it right there. Do it like that. Maybe from there. That's fine. D4 should be connected. Yep, that's good. Now it's easy. Now I don't have to think about anything. Just go on routing. There we go. Now just connect all of them. It's easy. It's good. This is so easy when you don't have to do anything other than just route them simply straight. You go. Let me connect this first. So I need to go to the bottom line right there. It's D14. I think I have made a mistake. It's D13. Yes, that's the mistake. Something happened. Yeah, it's stuck. It's got stuck somehow. Just try it from there we go. Okay, now so you need to go it in from the top layer itself, otherwise you won't be able to connect with that rat line. Ground ESP32, that's my mistake. So I need to just, that's a mistake. I won't be able to connect with the rat line if I'm making the track on the top layer of the PCB, since the rat lines are joining from the top layer of the copper, since I'm going to expose it. Let me just do it right there. Yeah. Now it's easy. Just connect, connect, connect. So many people are watching my live. What happened? Anyway, thanks everyone for watching. I'm not concentrating on the chat right now because I have to complete this design. It's actually needs some concentration, otherwise you can make every mistake. Thanks everyone for joining. So let me just finish it. Yep. Oh. That's it. Only a few more work left. Need to connect this. Maybe I can go from right from there. Nope. Can't make a connection like that. That's not good. That ain't good. That ain't good, man. Let me just connect the ones. I need to connect this, but I'm not able to figure out a way. It's not good if I connect it like this. Yep. Nope. It ain't good, man. I need to find a way. Need to find another way. Another way. Yeah, this might be good enough. If I can just connect. Yep. That's good. Now there you go. Another problem. Can just connect it right there. Connect it from right. Oh, no. Now I can't. Yep. I need to connect. If I need to connect this from this to, if I need to connect this to the 3.3 volt, no, the 5 volt, I need to make it in the top layer itself, otherwise it won't be able to go through that. Maybe I can just rotate this thing, then it will be much easier. Yes, that's good. That's the best way. That's the best possible way. That's good. Now let's connect the 3.3 volts right there. To connect them right there. Need to connect these. Yep, that's good. That's good enough. Go to the bottom layer. Need to connect. Which one? This. Okay. Need to connect this with the 5th pin, right? Nope, I can't make that. To find another way, man. If I can just move this a bit, it will be much easier, I think. Right, that's good. That's okay. You always need to make some adjustments in order to correct the others. But I don't think I'm able to do that. Let me just try. Try. Yep, that's good. That's okay. Now it shouldn't be that hard. Man, I forgot that I have to connect this too. I think I need to add some wire right there. Let me change it to the bottom layer. So, oh, nope, that's a bad idea that I have done there. Let me just think of another way. Is there any possible way I can do this? Like, I can go right this way, but need to find another way. I'm not that expert in this thing. I'm still a beginner trying to figure out things. Anyway, let's connect the other one. When you get tired of one, you try to do the other one. That's my way. I only need to connect this one right there, this red line. That is the 21. The 21 is the problem. Can I connect it? How can I? Yeah, got away. I think I can do a wire right here. I'm going to press B. No. This should be top layer itself. Can do a wire right there, and it should connect with this one. Which one should I connect? I actually forgot. It should connect with this one. That's the problem. Right here. W should be top layer. Let me just connect. Switch to the bottom layer, adding the wire, and there you go. It's perfectly fine. Yeah, it's good. Everything is looking good. So the routing is over. So now we just need to add some text and other things. Let me just what I need to do. Everything is fine. Now I'm going to add some text so that I know which one is which. So these are the 5 volts. Need to add text for that. 5 volts. These texts are necessary, otherwise you won't be able to tell which one is which. That's good. Proceed. That's 3 volt. 3.3. 3 be fine. I don't have the space to type in 3.3 volt, so 3 be fine. We got it right there. That's good. And this pin is actually full of ground, G and D. That's fine. This is actually for the MPU 6050. This, I think I need to look at the 3v3. So this 3v3. This is the ground. Need to write them. Where is the text? Should be topsil clear, right? This is ground. Joshua asked, am I gonna work with this board on your next video? Yes, I'll be working with the board every time, because as I said, this thing, the ESP32 doesn't perfectly fit on a breadboard, so I need that breakout board for every other possible videos and my other projects. So let me just get back to work. This is ground. ENT 3v3. I think that 3v3 is not that good. 2 volts. What's this thing? That's a seal. Shift up, seal clear. Rotate, yes. This is a better one. I didn't thought of it first. Can just rotate it right there. This will be SDA. Clear. Rotate. For the time being, I'm not going to add anything right here. It's actually for the MPU 6050, and it have got the XDA, XCL, ADO, and I'm not going to give them connections now. If I need them, I will do it. So just leaving the pins right there. So that's it. So next, need to check on this. This is good. U5, U4, yeah. This needs to be changed. This is 12 volt. So this is 12 volt. Control C, Control V. This is ground. Ground. Yep. 12 volt pin, ground pin. That's good. What do I need next? These are just ground pins. Okay, these are fine. Actually, everything looks fine. These are touch one. I don't think. Yeah, I can just add which touch is this. Let me just go and look at the. Need to refer the pinout. So touch 4 is GPIO 13. So I can just add touch 4 there. T4 will be okay. T4. It should be changed. It's top silk layer. Yes, that's T4. Need to copy. I think this is T9. Control C, Control V. T9. I think this is touch 9. I need to check. Let me just check once again. GPIO 32. It's touch 9. Yeah, it's correct. There you go. So now I think everything is fine. It's looking good. Around 5 volt, and I'll be checking it once again before sending it the files to the company, because I don't want to make any mistake in my PCB. I can't change anything if I have made some mistakes. Now I'm just going to add some more text, like just for show off. Just say V in. Let me just enter my name right there. VinVout-io. Can increase the no. Maybe 3. Let me just. That's good. It should go there. Is there anything I need to add? Anything I'm missing? I don't think I'm missing anything. So let me just add more text. So this is ESP32 Breakout board. Bottom silk layer. Yeah, this is fine. UARD. Then what should I add? Seed Studio Breakout board. Dino. So this Dino thing is actually, as I said, is my another project. So I'll be combining it with this. So let me just add that text too. There is nothing else. This should also be bottom silk layer. Can go right there. Yeah, I should add the. Let me just add another picture of our sponsor, that is Seed Studio, as a token of love for them. something happened. Anything? I think it got stuck. It's bigger than what I thought. It's bigger than my board. I need to do some adjustment. Computer PC is getting stuck. Let me just try to make it small. The image size should be like 3 millimeters. Be fine. Yeah, that's good. It's taking time. I don't know why. I could have made that a bit larger. Anyway, that's not a problem. I would say this should. I could have added that a bit bigger. Maybe I'll change it later. For now, it should. It's okay. Too good. It's good to see like that. So, as a final touch, now I need to add some copper on top of this, and the net will be ground, so every ground connections can be made. First we are doing the bottom layer. Yeah, building copper area. Taking time. Let me try once again. Some sort of problem. Now we need to do the same thing to the bottom layer too. So let me just add the copper area to the bottom layer too. After this, we just need to run a DRC check, that is design rule check, to know if there are any problems or faults in our PCB design. I need to expose this copper, otherwise it wouldn't be like what I need to. Expose copper. Now we are going to run a DRC check. Let me just, yeah, everything is good. DRC check. Yeah, there are no errors. So that's it. We have done our designing. So everything is working perfectly fine. I hope it will be working perfectly fine. The design rules check have been done and there are no errors. So let's save it first and take a look at the 3D model of it. And here we go. Here we have the board, and this is how it will look when I get the thing. Yeah, it's good. Let me just rotate it right there. Everything is fine. Yeah, this is actually really good. I prefer the color to be in green. Yeah, that's good. and the surface finish will be silver, and it would look like this, and this is absolutely fantastic. And I will be doing some more check, and I will send the files, Gerber files, to the Seed Studio, and they will make or fabricate this PCB and will send it to me. Hope this works fine. Thanks guys. So this is the end of the video, and thank you so much for sticking with me. There are so many people, so thank you friends, thank you so much for coming. And you guys have been actually messaging me or chatting with chatting in the space for that. There are so many chats I need to read. Bro, big fan. Bro, can there Devo. Yeah, your skill is one of a kind. I'm really proud of you for sharing it with us. I don't know when, but one day you'll become a legend in this field. Thank you, Dia. Thank you so much. Thank you, Aditya. Thank you, Rohan. Thank you, Joshua. Thank you, Calix. Thank you, Sean. Thank you, Subin. Thank you, Anantu. Thank you, Shamnad. Thank you, everyone. Thank you so much. If I have missed anyone, don't feel anything. Just thanks. Thanks a lot. So, so that's the end of the video. So thank you so much for sticking with me, and I will come. I will make another video when the PCBs are right. And thank you so much. Now, good night. Bye. I'm going to end this session. Thank you so much.